Our first speaker is Andy Dennis from Modus Create, which is a consultancy firm. And take it away, Andy.
All right, you all hear me okay? So, yeah, first of all, thank you everyone for coming out on this rather wet and muggy evening in New York. It's it was fun getting over here from the AWS event. We got kind of rained on. So this evening I'm going to talk about baking static analysis into your CI pipeline. So really this talk is a byproduct of some of the work I've done over the last 2 years, just some ideas that were percolating and how I've seen things being done, and then thinking about how can we automate this and do something a little better. So let's start off with just taking a quick look at some typical security items. A lot of companies, they will have a number of security initiatives, and sometimes the DevOps teams are involved, sometimes they aren't. It really just depends on the maturity of the company and how the teams are divided up. So you'll have firewalls which can be used to block traffic. If you're working in Amazon AWS, you might have the WAF installed. You'll have AVs to scan for viruses and malware. You'll have teams that may be spending time hardening the operating systems of servers, maintaining patching schedules, and just generally helping to mitigate against vulnerabilities. And then the above in turn can be bolstered by intrusion detection systems. So we've got NIDS and HIDS there. And then finally we can gather our logs together and analyze them using SIEM. So we've all heard the term cattle, not pets, I'm sure, or snowflake servers. So the DevOps process is, being able to address this to a degree. Certainly from a security perspective, it's allowed teams to ensure that servers and environments are deployed and built in a consistent fashion. And that security issues can be addressed once, and then once they're fixed, the infrastructure can be deployed multiple times without that issue reappearing because someone manually configured a server or, opened a port or whatever. But the question is, what about software? How do we address the security issues at this level and at least automate some of that process, like we've done with servers and infrastructure? So software security, on the engineering side, there's a number of techniques folks use. So we've got stack canaries, we've got use of safe functions. Certainly, in C, you've got the choice between using safe functions and unsafe functions. We can sanitize inputs to applications. We can write unit tests to ensure that the code's doing what we expect it to do. And then we can write fuzz tests so that we can hit it with different inputs and ensure that the program doesn't crash in a fashion that we're not expecting or reveal some other security issue like a buffer overflow. And then, there's the OWASP top 10 guidelines. I'm sure some of you here are familiar with them. It's a good idea if engineers read them and try to follow them to the best of their ability. They're a great resource. If you go check out the OWASP website, you can find a good guide that was updated, I think, in 2013 was the last edition. So what is static analysis then? So we understand engineers can write code that perhaps is secure. We understand that DevOps can harden servers. They can make it a repeatable, deployable process. But then what happens if someone makes a mistake? What happens if someone misses a security issue or something along those lines? So the risk of insecure software being deployed to a server can be exploited by a malevolent party. So for all the steps we take in slide 2, we still have risks of holes in our systems. And this is actually where DevOps can step in and help still. By helping to roll out static analysis tools. So what exactly is static analysis, you might be wondering. So it's a mechanism for scanning code for known security issues without having to deploy and execute the source code. Broadly speaking, the term contains a number of areas. So linting is something perhaps some of the engineers in the room are familiar with, which can check that the code meets stylistic and syntactic requirements of the language. Some aspects of static analysis use formal methods, so mathematical methods for reviewing the code base, which includes taint analysis, control flow graphs, and so on. Then there's license checking. That might not immediately come to mind, but some companies find that engineers have installed applications and they don't have the correct licenses that are compatible with whatever the policies are for the company or their department. Then there's dependency checking. So that's really checking that the dependencies that are being pulled in are safe. I think recently there was it ESLint or one of the packages I saw yesterday, there was a major security flaw found. It was being pulled in via NPM. So I think it's always good to check those and make sure you're not pulling in anything that's potentially a security threat. And then, as I mentioned before, static analysis can also check for insecure methods and the OWASP top 10 guidelines. So we go on to the next slide. So there are a wide range of products in the marketplace. Some of you may have heard of Black Duck or Veracode or SonarQube. You can find a comprehensive list at the OWASP website. You've got a choice between standalone scanners, which can be integrated with the IDE. So the engineer can run it in their IDE and it'll scan the code base, as they're going to see if there's security issues. Then you've got the server-based ones where you can upload the code to it and it'll scan it and it'll generate a report and kick it back. The products I've listed here, Black Duck's great for scanning applications for use of open source products. So for example, JavaScript libraries. Veracode is a SaaS-based platform, which has a pretty comprehensive static analysis tool set there, and it covers a variety of languages, and it can produce pretty detailed reports, which are pretty good if you have to hand them off to management. And then SonarQube, which is a favorite of mine, is a static analysis tool that's free to use for open source projects. So you can just log in with your GitHub account and start using it if you've got an open source product. So let's take a look then at why does DevOps care? So you're probably wondering, why is it your job to scan code for security issues? Why can't the engineers do this themselves? Which is a pretty good question. And really they should. Engineers should be doing this as part of their job. But we all know that that doesn't necessarily happen because of deadlines and management requirements and resources. So it's just it's the nature of the beast that it doesn't always get done. If an engineer forgets, that can be a problem, but this is where DevOps can step in and help. So scanning is part of the CI pipeline. It can allow us to take a release tag, for example, scan the whole thing before it goes out the door to make sure there isn't security issues in it. We can have it as part of the commit process. So you commit some code, and then you can perhaps have Jenkins pull it out and then run the scan against it and generate a report. All of these mechanisms, by automating it, essentially take it out of the hand of the engineer. So if they do forget, you've got this sort of fallback mechanism there to help you. So really, yeah, by integrating as part of the CI and CD process, it allows us to examine the bigger picture as part of the whole project. So the first step, perhaps, as I said before, some of you are familiar with, is linting. Linting, it can be done via Jenkins. It can be done manually, locally. I actually kind of like doing it via Jenkins, and I'm just going to put the dashboard here. So I've integrated ESLint. So if any of you are familiar with JavaScript projects, it's pretty simple. I can configure a task basically in Jenkins. I've taken a JavaScript library here called Beep, which is it's actually a project we're going to open source soon, which plugs into the Have I Been Pwned API. So you can type in your email address and it'll tell you whether it was part of a breach somewhere. So I've added just a couple of quick bugs to it just to demonstrate this. But if I run the build now process, and we can just click on the job here. So basically what this is doing is it's taking the project, it's installing it on my local laptop, but wherever you're running Jenkins, and then it's going to run the linting tool against it. It's going to generate a report, which is then going to get returned as an XML file to Jenkins, which then an engineer in theory could jump in and take a look at and figure out where the bugs are. So we'll just wait for that to finish running. All right, great. So we can see it failed, which is actually a good thing. Get back to the project, and we click on this. We can see there's some warnings here. This is kind of nice. It'll tell you the bug. It'll tell you when you click on it, the line in the file. You can see here, added an extra semicolon, so it's flagged that as an issue. So this is kind of the first line of defense, I would argue, and it's typically, as I say, engineers will run this locally, but you can put this as part of your CI pipeline. You can have code that's committed to GitHub pulled out, and this test can be run, and you can say if it fails the tests, it doesn't get deployed. Now, how strict you make that linting process will really depend on the language and, and your tolerance for messy code, or, how serious you think it is. But this is what I'm going to argue is the first step really in static analysis is the linting step. So I'm just going to jump back to the slides now. So the next thing I'm going to talk about is SonarQube. And well, I'm going to use that as an example of more of a full-blown static analysis tool that has quite a number of features. So SonarQube is, as I mentioned, it's free to use for open source projects. You can sign up at sonarcube.io. And in case you're wondering, sonarcloud.io, sorry, which can be found here. And what we typically would do is, in Jenkins, we can configure the plugin. So it's pretty simple to set up. Create your own sonarcloud.io account using your GitHub account. And then any of your open source repositories, you can then configure them so that you can then point a job in Jenkins to it and run it, and it will then take all of the results from that and push it back into Jenkins. It'll push it back up into Sonar Cloud, so that then your engineers can log in and take a look and see, okay, where's the security issues here? So we'll just do a quick example of this now. So I'm going to go back to, this is the SonarQube job I have configured here. Sorry, it's running a little slow. Right, so I'm building this here. Take a look at the console output. So what this has done is it's taken the configuration I've set in Jenkins, which is really just the project name, the organization, which is going to be your GitHub user, and then the project itself, which is checked out. And it's going to run this test against it, which takes a few moments. And then once this is finished running, what we'll do is we'll take a look at the website so we can see some of the results that were pulled out of the test. All right, it's still running. Thankfully, I have a fake and bake, which I did earlier, so I can pull this up. Right. So here we go. This test actually failed because there was no code coverage. We can see here, though, that whereas the linting simply just showed us, some syntactical errors or some styling errors, this is far more comprehensive. We can take a look at the fact that there's no test coverage. This will give you an example of bugs and vulnerabilities. Code smells. So this is technical debt. This value here, where it says 2 hours, that's effectively how much work it would take to fix this piece of code to bring it up to modern standards, as it were. So that's kind of a nice feature. And then we can see if we dig into some of these tabs, they go into quite a bit of detail, so you can actually drill right in and see which line of code needs to be fixed. And then the rest of the tabs here are just metrics that are quite useful for the engineers to look at. So that's just a couple of examples of tools that we can use as part of the static analysis process. As I mentioned before, there's many features. Sorry, let's go to here. So beyond the two I demonstrated, there are really quite a lot of different options out there on the market, and depending on your budget, depending on the languages you're using, really, you can go out there, explore, and then figure out how you can take that and integrate it as part of your CI pipeline. There is the OWASP dependency check. That's another example of a product you might be interested in checking it out. It's out there in Jenkins. And then on a final note regarding that is testing. So as you saw, there was 0 tests with that piece of source code back there. I think engineers should always include tests, and then DevOps can always ensure that they get run. So that's a step that can also be included after the linting or before the linting. I mean, that really depends on a bit of an argument of when you think it makes most sense, but including the testing as part of that process. And that can be unit testing, API testing, it can be fuzz testing, like I mentioned before, as part of the CI process. This extra layer of security may end up sort of saving the day sometimes. So yeah, so I just want to finish on just a note saying then that if you're planning on using these tools, you can obviously set up an AWS account. It's free. You can set up a EC2 instance in there. You can try some of them out and really get a feel for what works. And then once you feel happy with it, then the next step is you can then look at how do you slowly integrate that into your existing CI pipeline, which, as I say, depending on your language, is going to really depend what tool you chose. So I will wrap that up there then and open the floor to questions, please. Oh, hey, good catch.
I was going to get it. Was pulling straight from, well, NPM, right? As opposed to like storing as an artifact. I don't want to just ask, what are your opinions on dependency management and artifact versioning, but how does that interface? What are the implications as far as build time or CI/CD linting?
Right, so just to clarify, you're asking regarding build time, how does that impact? Right, and sorry, how does that impact? I didn't catch the last bit.
How does it, what are the?
Oh, okay, right. So if I understand your question correctly, what are the implications of having dependencies and then running linting against them? Oh, so sorry. So right. So literally your own repositories, right, inside GitHub. Yeah. Yeah. So yeah, absolutely. I mean, you can configure it to do that. There's no reason why you couldn't set it up so that, for example, the project we showed, Beep, has its own dependency in our GitHub account. I could extend that so that it checked out both the repositories and ran linting against both of them. Yeah, that's feasible. I mean, I think the biggest problem is when you're pulling in third-party dependencies. That's really where the risk is. I mean, if you've got control over your own code base, then you have more ability to ensure that the security is maintained there. The real risk is, yeah, when you pull in something that's, say, out of date, a tool like Black Duck will scan that code base and it'll tell you, okay, you're using an old version of jQuery, an old version of React or something like that, and it'll flag it. But yeah, I mean, that's one of those risks. If you don't maintain the code base and stay on top of it, then you're asking for trouble. And I think that's why using these tools helps, because it can be very easy for that technical debt to be accrued when no one's paying attention to it. But if you're running this as part of a CI process and it keeps getting flagged, then hopefully eventually someone's going to at least pass it back to the engineer and say, this is a security issue and we really need to fix it. So I hope that answered your question. Yeah. Anyone else? Oh, okay, right, let's see if we can. Yeah.
So you mentioned that one of the tests you can run is for checking the licenses against your dependencies.
Yeah.
Do you do that, and do you find that it's very reliable?
Yeah, so that's a good question. We have done that. One project I worked on, we used Black Duck. We hadn't baked it into the CI process at that point. We were just taking the tag out of GitHub, zipping it up, and then uploading it to the hub, they call it. It was pretty reliable. I mean, the code base had a lot of outdated code we knew about, and it had flagged much of the stuff we'd seen when we'd done a manual review of it. So yeah, I mean, certainly from my experience, it's been pretty good, yeah. And it was pretty good at highlighting the licensing, although some of that could be considered noise, whether it's a Apache license versus MIT. But yeah, I found it's pretty good. Ooh. We've got one over here, please. Oh, thanks.
Wow. So developers are always complaining that build times are too long.
doing this on every iteration seems like, well, to me, seems like the right way to do it. But what do you recommend, or I guess my question is, do you have any measurements about how much longer this makes the CI pipeline in typical installs? And also, what would you say to developers who say, let's not run this every single time?
Yeah, that's a good question. So I can tell you, certainly from one major product we used, we had a particularly large PHP application we loaded in it, and it took days to run the scan. Said product added in incremental reports. Originally, they didn't, so you just had to sit back and wait. And then they added in sandbox areas and incremental reports, so you could start to see it. I think it's really a blend. If engineers can integrate, some of the code linting steps and the static analysis steps during the development process, or even as like pre-commit hooks to get things like that, then by the time the code gets into the source code repository, it tends to be more hygienic. The question is, do you want to run this every single time on every commit? Probably not. Do you want to have it as part of a deploy process? So, for example, if it's going to a staging server or UAT, I would say, yeah, that's. But it's really a balance. It depends on the size of the code base, the language, the product you're using. So yeah.
So, yes. Oh, this is a mic?
For those of you who are new, there's a microphone in this cube. It's not just like a...
I thought it was a toy. Okay. From experience at a past employer, something which works well is to tie this kind of static analysis and quality analysis to a pull request, so that the developers get informed when they create a pull request, whether their pull request is creating new quality issues, and also the person is reviewing the pull request gets this information. I think that's the best approach.
Yeah, I agree. I think doing it on the pull request is good. There's definitely an argument, though, for doing it on the tag, because if you've got multiple pull requests being, pulled into a branch, there's still a risk, that if there's a merge issue or something, someone doesn't spot it, and then doing it on the complete tag at the end is still, I think, still a good idea. But I think doing it on the pull request is a good time to do it. Yeah. All right. Anybody else? Oh, here we go. Two more.
Hi. Yes. Question is, like, what is the worst security issue?
I would say a particularly old code base. We found about 130 SQL injection issues. And that was out of the 3,000 issues that the tool had flagged. I mean, the bulk of them were minor, but yeah, the 130, they were pretty serious. All right, there we go.
Have you ever seen a legacy code base just sit there without commits and slowly accrue more and more static analysis issues as new technologies evolve, or as dependencies get bugs, or I can imagine, let's say, a new version of Python or Java is released that has a new, better way of declaring streams, and so, etc.
Right. Yeah, yes, absolutely. In fact, I've seen a code base that was continued to be committed to, where they just weren't updating the dependencies. They did not update the version of the language, and it just got worse and worse over time. Yeah, absolutely. I mean, I think that's probably a common problem in many companies, that they have legacy code bases, but there's just not the budget or the willpower to upgrade it, or it takes just a very long time because of red tape. Oh,
I drink that way. So actually, I'm mostly familiar with compilers on that, and we would do something like for a regular build, we have a full debug, but then for a release build, you have you turn off the errors being, the warnings being errors, because if you don't, then sometimes people freak out when the old code stops working. But I'm not really as familiar with the build procedures on other languages to know if that's an option. But that's kind of routine for a lot of code that way.
all right, thanks. So anyone else? We good? All right, well, thank you all for listening to this.